Hello and welcome back. In today's video we're going to be talking about triangular and square numbers. We'll see what they are, how to visualize them, and how they're related to each other. So to start, what are triangular numbers? So a triangular number is a number that can be arranged as an equilateral triangle of dots. So for example, 1 dot is going to be our first triangle, and then we'll add another row for our second. So it'll be 1 dot up top with 2 at the bottom, meaning 3 dots. Then our third one is going to be 1, 2, 3, but now we add another row on the bottom. This time going to be 3 dots, and then we'll keep going like that. So if we look at the amount of dots, that's going to be our triangular sequence. So our first one's 1, our second one is 3, our third one is 6, and then our fourth one would be 10, and so on. So as you can see, we have the formula up top already, but we'll write it out. So our t of n, which is our triangular number, is equal to 1 plus 2 plus 3 plus all the way up to n, which equals to our formula of n plus 1, all divided by 2, which is going to be very important later. Now, what are square numbers? So square numbers are numbers that can be arranged as a square grid of dots. So for example, our first one is still 1 because that is 1 squared. Our second one is going to be 4 dots because that's 2 squared, and our third one is going to be 3 squared, so 9 dots. And then it keeps going, meaning that our square numbers this time are 1, 4, 9, 16, 25, and ongoing. So let's look at a couple of examples. So our first question is going to be writing our numbers as sums of triangular numbers, with our first one being 56. So we're going to look for the largest triangular number that is less than or equal to 56. So now if you do a little bit of trial and error, you'll find that t of 10 is equal to 10 multiplied by 11, because that's our 10 plus 1, divided by 2, which gives us 55. Which is extremely close to our 56. So we know that this is the largest triangular number. However, we know that we still need to make up our 1. But if you remember, our t1, which is our original value for the triangular numbers, is equal to 1. So we're able to add the two together to get that the 56 is equal to t10 plus t1, which again is 56 is equal to 55 plus 1. So just like the last question, we're going to do a little bit of trial and error to see how close we could get to 185. So after a little bit of looking, you'll get that t18 is equal to 18 times 19 divided by 2, which gives us 171. But we know that we can't go any larger because t19 is equal to 190, which is obviously too big. So now we need to make up the difference. So in order to find that, it's just 185 minus 171, which gives us 14. So now we know our base is going to be t18, and whatever triangular numbers will add up to 14. Now what we can do is we're able to just look again at how 14 could be split up. So we know from before that our triangular numbers can be 1 and 3. And if you look at a couple of the other numbers and the rest of the sequence, it goes 1, 3, 6, and 10, where 1, 3, and 10 would actually equal up to 14. So we'll have our t1, which is equal to 1, our t2, which is equal to 3, and our T4, which is equal to 10, meaning that 185 is equal to T18, which is equal to our 171, plus T4, which is going to be our 10, plus T2, which is going to be our 3, and finally T1, which is going to be our 1. So this is going to be our final equation. So our next question is going to be finding numbers that are both triangular and square. So we want to satisfy where n and n plus 1 divided by 2 is equal to our square of m squared. So our first question is going to be 1,225. So the first thing that we can check is if it is square. Since it's much easier to look for, as all we have to do is check if m squared is equal to 1225. And we'll notice that if you just take square root of both sides, m would be equal to 35. Since 35 squared is equal to 1,225. So now it gets a little more complicated because we have to check to see if it's a triangular number. So we're going to set n plus 1 divided by 2 equal to 1225. So the first thing we can do is multiply both sides by 2 to get rid of our 2 in the denominator, giving us n plus 1 is equal to 2,450. Now we can factor in our n to give us n squared plus n, and we'll bring our 2,450 to the other side, making it minus 2,450. So we can set to 0 and make a quadratic equation. So now if we plug this into the quadratic formula, where we get n is equal to -1 plus minus the square root of 1 plus 4 times 2,450. Since the negative will make it a positive and 1 squared is just 1, all divided by 2 multiplied by 1, so again it's just 2. We're able to compute the discriminant, which is our part under the square root. So under the square root, I'll write this in a different color, is going to give us 9,801. So now we need to check to see if 9,801 is a perfect square, since it will be under the square root to see if it will make our life easier or harder. So if we take the square root of 9,801, this will actually give us an answer of 99, which is nice because now we get to work with a whole number. So we get our two equations being n is equal to -1 plus 99 divided by 2, which gives us 49, and n is equal to -1 minus 99 divided by 2, which gives us -50. So since we need our numbers to be positive, we have to discard our n being equal to -50, which means that 1,225 is equal to t of 49, which is equal to our 49 times 50 divided by 2 if you want to put it in the formula just to check. And finally, we'll end off with a little bit of a nice formula to know, just in case, where our s of n is equal to tn plus 1, which we can simplify and prove as n squared is equal to n plus 1 divided by 2, plus, and then this is going to become n plus 1, n plus 2, all divided by 2. So now we can see that they have the same denominator, So we're able to factor out one of the n plus 1s. So we get n plus 1 multiplied by n plus 2, and we're going to divide this all by 2. So now this will give us n plus 1 multiplied by 2n plus 2, all divided by 2. But now you can see that this is actually going to be equal to n plus 1 squared. But since n plus 1 squared is exactly Sn, this means that our Sn is equal to Tn plus 1 is true. So today we talked about triangular numbers, square numbers, and the overlap between the two. See you in the next one.